In this next example, you might realise that part A is actually a hint for the for answering the subsequent parts to this question. I guess it's a little bit difficult if you haven't had a read through the question. So if you maybe just pause the video now and have a read through the question so you're familiar with what I'm talking about. So looking at A, it's not asking you to get the locus. It's just said, given these points, these 3 points, find the gradients of AP and BP. So if you were reading that, you would think, oh, I hope you would think, it's not asking me for the locus. But the fact that it's asking you to calculate the gradient, like I've said, is a huge hint as to what will be required for later in the question. So, yeah, really, part A is really straightforward. Maybe you could plot A and B like we have been doing, just to get some visual understanding of what's going on. You might read this and see that A and B are specific points. P is your abstract X, Y. It can vary. It's, it doesn't have an exact location. So what I might do is pause the video and sketch it up, and then come back and write up some solution, and then come back and talk about it. Okay, so now you can see that I've just followed the instructions of part A, in that it is just instructing you to find the gradient. Now, in terms of levels of difficulty of questions, we'd have to say this one is very easy. You'll find that any question that gives you the straight out mathematical process that you're going to use will be deemed a very easy question. You'll see in part B that that's not the case. It doesn't tell you mathematically what you need to do. Hence, it's a more difficult question, but these are the questions that are really stretching, I suppose, your ability to apply your processes in maths in practical applications. You will hear me refer constantly to this more mature way of thinking about maths. Processes are only ever developed because they have an application. However, you'll hear me probably at some stage saying, we won't actually get really to use this. This is just a straight out process that we need to learn. And the reason for that is because we don't have enough time to explore every application of a mathematical process. But back to this one, you can just see that I've simply found the gradient using y2 minus y1 over x2 minus x1. And I've always let my p be my x2, y2. So in AP, A was my x1, y1, and I get the gradient is y over x minus 4. And likewise, the gradient for BP is y over x plus 2. Now, they've really been very kind in this question. You would probably have read that and wondered why you're doing gradient. Well, you'll see in part B exactly why they gave you that instruction. Clearly, there was no reference to locus, but here now in part B, they are asking you to show that the locus of the point, which moves so that this angle is a right angle, becomes x squared plus y squared minus 2x minus 8 equals 0. Now, so this is obviously now a locus question. I don't think there would be many people that would recognise that description, that when you've got 2 points and you take their gradients, and their gradients must always be perpendicular, they must always form a right angle, that you would get a circle. We know that this is a circle because it's has an x squared and a y squared in it. So we already know that we're going to get a circle from that. I would find it difficult to extend my diagram with finding more points, red crosses, to form the circle, but that doesn't mean that you would, and I know that a lot of you will have a better visual concept of mathematics than I do. And if, you might be able to see how to extend that. But we wouldn't really spend a lot more time on the actual diagram and the visual representation. We would probably just get straight into the algebraic solution. So when we read this question, if we don't pay attention to the detail, and the biggest key word in this actually ends up being the fact that they've said here that the angle is a right angle. So one, you've really got to pay attention to that detail. It's a right angle. What do you conclude from that? You can conclude from that angle APB is, if it is a right angle, then AP and BP must be perpendicular. And once you've established that, you then go on and make the connection to, well, if two lines are perpendicular, their gradients must multiply to give a -1. And you finally see the connection between this and what you were asked to do back in Part A. Why were you asked in Part A to find the gradients? Because you're going to need to use those expressions for the gradient in Part B. So, like I said, they've made this a little bit easier in that they're stepping you through the solution. You can expect in the future a question that starts here at B. You're given 2 points, but you're starting at B. You're told that this condition, that the angles that are formed as a right angle, and away you go to, it could be still a show question, and so you're trying to produce this equation, and you have to make the connection to the concept between right angles, perpendicular, gradients, and getting your expression. Once you've got this written down, it's just a matter of following through with your algebra, and you will get the expression x squared plus y squared minus 2x minus 8 is equal to 0. Part C is back to an easy question where they're giving you the instruction, complete the square. That's a technique you've learned. That's the instruction in the question. This becomes an easy question. There's no great mathematical thinking required to do this. It's a process. And your processes have to be automatic. It's the more difficult aspects of maths is actually knowing where to apply them. Your actual mathematical thinking. And that's not being tested in Part C. So we're completing the square, and yes, we're getting a locus, centre 1, 0, radius 3. And of course you'll just pause this at any time if you need to go back and work through that yourself and see where all that comes from. I think the interesting thing about this question is that we would rarely ever come across, or you've probably never come across before, the geometrical description for a circle in this format, that you will get if you take the set of points and you select 2 specific points, and we'll identify what those 2 points actually are, and say that the set of points forms such that the angle from this specific point A to your abstract P, then back to B, forms a right angle, then you will actually get a circle. It's a very different description for a circle. What we can actually see is that these 2 points become a diameter. So we've said that the centre is here at 1 naught, and we can see the radius is 3. So this here from 1 to 4 is 3, from 1 to -2 is 3, and yes, we're going to get this circle which radius 3. So that's actually my set of P points forming the circle. This is a wonderful exercise that actually forces you to think more maturely, applying your techniques in different situations, paying attention to detail of the question, things being presented very differently, and not always getting the instruction, being given the instruction of what mathematical process you need to use. Your ability to deal with all of that is a measure of your mathematical maturity, which is something that you're managing very, very well. And I hope you enjoy doing exercise 9A. And think about the fact that you are able now to take these concepts that you've learnt and processes you've learnt and apply them in really different situations. And hopefully you're becoming a lot more confident that that's what you are able to do with your maths.